4.10. So there's a guy who's pushing an ice block for 11 meters and it takes him 5 seconds. The first thing that asks us is to find the mass of the ice. So we're going to eventually use this equation, force equals mass times acceleration, which is Newton's second law. But the first thing that we have to do is find our acceleration. And we can't just go 11 meters divided by 5 seconds divided by 5 seconds to get meters per second squared. It doesn't work that way. So we're going to do it this way. The initial position of the block of ice is 0. The initial velocity is 0 because it was at rest, so that whole thing equals 0. So now we can just plug in what we know. It travels 11 meters, and that is equal to 1/2 times the acceleration, which is what we're trying to find, times the time that it traveled. And it traveled for 5 seconds, so I'm going to square that, and that is 25. So then we can just keep calculating this, find it algebraically, multiply by 2, we get 22.0 equal to 25a. Then we would just divide by 25. And when we divide by 25, we find that our acceleration is equal to 0.88 meters per second squared. So now that we have our acceleration, we can go ahead and use the force equals mass times acceleration, but we're solving for mass. So what we're going to do instead is mass is equal to force divided by acceleration. And the force that was applied was 80 newtons by the guy who was pushing it. So that's going to be 80 divided by our acceleration, which we calculated to be 0.88. And that is equal to 90.90 kilograms. And that's the mass of the block of ice. And the second thing that it wants us to know is the distance that the block goes after the guy pushes it. He stops pushing it, and for 5 more seconds it's going to move, and we want to know how far it's going to go. So we're actually going to use the same equation that we used in the last one. But this time we're gonna kind of do it relative. So the x position is not going to be the 11 meters that already traveled, because we want to know from where it was how far it traveled. So from where it was is going to be 0, and then we're going to make, oh, wrong one, this one's 0. Okay, so we don't know our x, that's what we're trying to find is our x. And that's equal to the initial velocity. Well, we can calculate that. We can just do 11 meters that it traveled last time divided by the 5 seconds that it took. And this time it's traveling for an additional 5 seconds plus 1/2 of the acceleration, which we calculated last time. Wait. Yes, that's correct. Whatever. Times our 5 seconds squared. Hold up 1 second. Oh. Let me just show you what I have written down here, because that got me the right answer. So we have velocity that it's going to be traveling. That's going to be equal to the initial velocity that it was going plus the acceleration and the time. So our velocity it's going to be traveling is equal to, well, it had no initial velocity. That's 0 plus, oh, is that the same thing? No, it does not. Okay. So times our acceleration, which is 0.88, times our time, which is 5 seconds. And that equals 4.4 meters per second. That's the velocity that it's traveling. And then for our x, we say x is equal to the velocity that it travels times the time, which is 5. And that's equal to 22 meters.